Hello everyone. Let's take a look at section 18G, which is called Binomial Probabilities. Now you should notice the word binomial there, so what we're going to use is the binomial expansion. But how does this relate to probabilities? Well, first of all, let's take a look at the experiment that we're used to. This is the 7 red and 3 blue marbles. Okay? All the marbles are exactly the same except for color. Now what we're going to do is we're going to set some parameters about the event itself, the experiment itself. And we're going to say these 3 things are true. 1, each trial is identical and independent. Okay, that means of course that we're starting off with the exact same conditions every time that we run the experiment. There are of course only 2 outcomes. And of course we only have 2 outcomes because you can only choose a red or a blue marble. And let's say, for example, that we have a finite number of trials. So in other words, we're taking 10 trials, 15 trials. It's not an infinite amount of trials, it's a finite number of trials. Now there's a couple of things that we should recognize here if we go ahead and put this into what we would call our tree diagram. And let's take a look at what this looks like. Now notice that if we go ahead and analyze the tree, notice that each trial that we have, and let's just say for now that we only have 3 trials, each trial is going to be exactly the same. So notice that the probabilities for each trial is 7 over 10 for the red and 3 over 10 for the blue. So notice that that's the same here, that's the same there, that's the same there, and that's the same there. Okay? Now of course, let's go ahead and generalize a little bit more and say, let's say for example that the probability of red is actually P and the probability of Q is actually going to be the 3/10. So let's say for example this was the 7/10 here and this was the 3 over 10. Now notice of course what we can then say is that when we add these 2 probabilities together you always come up with 1. Okay, now this is what the tree looks like for this particular event with these particular conditions or parameters for the event. This is called a Bernoulli experiment or a binomial experiment. Okay, and it's because we have these 3 characteristics. Now how does the binomial expansion come into play? Well, let's go ahead and take a look at what our binomial expansion will be for P plus Q raised to the 3rd power. Now we know how to do that using Pascal's triangle, and we can also go ahead and use our calculator. We know that this is going to be 1p to the 3rd q to the 0 plus 3p to the 2nd q to the 1st plus 3p to the 1st q to the 2nd plus 1p to the 0 q to the 3rd. Okay, now if we go ahead and take a look at what we have here, instead of using 7/10 and 3/10, what I'm going to do is I'm going to replace that with p and q. So let's just go ahead and take all of these probabilities that we have here. And let's go ahead and replace all of this with P and with Q. Okay? So here we go. All the reds, the probabilities of red, of course, are P. So P, maybe I should just go and just do it this way. Okay, so here's P and Q. Here's P, Q, P, Q, P, Q, P, Q, P, Q, P, and Q. Okay, so look at what happens then if I was to go ahead and say, let's say for example, I have, what is the probability of having 3 successes? Well, if I take a look at 3 reds, if I take a look at the probability of 3 reds, then if I was to follow this tree here, then it would be the probability of this times the probability of that times the probability of that. And notice that it's actually just going to be p to the 3rd. So that's where this comes into play. You have 3 choices of red, you've chosen 3 marbles, and you've chosen no blue marbles. Okay? Now if we go ahead and take a look at, say for example, choosing 2 red marbles and choosing only 1 blue marble, then the number of possibilities that I can have with 2 P's and 1 Q, that's one branch. 2 P's and 1 Q, that's another branch. 2 P's and 1 Q, that's another branch there. And that's the only possibility that we can have. So notice that if I was to go ahead and take a look at the probabilities associated with getting 2 red marbles and only 1 blue marble, then I have basically 3 different paths that which I can choose, which of course include P squared times it by Q. So there you go again, there's the 3 P squared Q to the first. Now, let's take a look again. Say for example, if I was to go ahead and talk about having only 1 red marble and 2 blue marbles chosen, well then the path is this one red and 2 blue. So 1 red and 2 blue. Here's 1 red and 2 blue. And here's 1 red and 2 blue. And sure enough, notice that what we have is we have 3 different possible ways of coming out with 1 red marble and 2 blue marbles. And sure enough, there you go. 3. So notice again, let's think about the choose notation as well. This is 3 choose 1, right? Because you're choosing only 1 red marble and 2 blue marbles. So the last one, of course, is going to be very straightforward in the sense that we can then go ahead and say that if we wanted to find the probability of choosing all the blue marbles, well, here you go. There's only one way of choosing 0 red marbles out of 3 red marbles. There's only one way of choosing no red marbles and choosing 3 blue marbles. And sure enough, that path is described by this path there. So, if we actually take a look at this here, this P plus Q raised to the third, which is our binomial expansion, is actually going to describe all of the probabilities that are possible for this particular Bernoulli experiment. Now we need to go ahead and of course expand this to more than just 3 trials. This is just 3 trials. But we know how to do that because we know how to expand this for any particular value of n, and that particular value of n is going to be the number of times that we repeat the trial. So in general then, is if we say in n trials, if P is going to be the probability of success. Now whatever that success is, you determine. And Q is the probability of failure, which of course would be the opposite of success. Then, if we wanted to find the probability of finding K successes, then all we really need to do is find the associated value in the expansion, and this is what it looks like. And all of us are familiar already with what this represents. So, what we can do as well is, of course, sometimes this can be a little bit difficult because there's so many different values and the numbers can be so large. The graphic display calculator will also be able to give you these particular values very quickly if you use the binomial probability distribution function. Okay? Binomial probability distribution function. This is the number of trials, the probability of success, and how many successes that you have. Now, there's also another one that's called the binomial cumulative distribution function. Cumulative distribution function. And notice that the values are the same, but what it represents is a little bit different. It says this is the probability of all successes up to and including k. So say, for example, if I was to do this one here and said that k was equal to 2, then I would be finding the probability of having just 2 successes. But if I was to calculate it using the cumulative distribution function, I would actually be finding the probability of having just 0 successes, 1 success, or 2 successes, and adding all of those probabilities together. Okay, so there you go. That's how you can go ahead and use the binomial expansion with a Bernoulli experiment to determine the probabilities of any particular result that you're looking for. Okay? Well, take a look, give it a shot, and we'll see you the next time. All right, bye-bye.